In this video, we're going to talk about ratios, rates, and unit rates. So let's talk about ratios first. For example, I have this sentence here. It says at the last dance, the ratio of girls to boys was 28 to 21. So we had 28 girls and 21 boys. Now the first thing you can do is you can write a ratio in three different forms. The first form is right here, 28 to 21. You simply put a 2 in between the two numbers that you're comparing. In this case, girls to boys, and you have a ratio set up. The second way is you can put a semicolon or just a column in between the two numbers, just like I have right here, 28 to 21. And the last way, and this was going to be our most useful way of writing it, at least for us in the foreseeable future, is to put a division line between the two ratios, or the two numbers, 28 to 21. So these are the three ways you can write that particular ratio. They all mean the same thing. The next thing we want to do is to simplify ratios, because when it comes to numbers, looking at them in their simplest form is the best way to work on them. So this is what we're going to do. We are going to use the last form right here. Again, the other two forms, they're the same thing, but mathematically, the fractional form, as I like to call it, is the easiest one to use. So we're going to stick to that one. Now, can someone tell me, how can I write 28 other than 28? What times what can give me 28? We could have said several things. 2 times 14, or maybe 4 times 7. I'm going to stick with 4 times 7, and you'll see why in just a second. So I want to write the numerator in this case as 4 times 7. I'm going to write the denominator as, what can I write the denominator? Here it's a little easier. What times what can give me 21? 3 times 7. You might have guessed by now why I'm doing this, but what can I do right here to simplify this particular fraction? If you said cross out the 7s from the top and the bottom, you're correct. Cancel time. But this a long time ago to simplify fractions, so. And what does that leave me? It leaves me just the 4 on the top and the 3 on the bottom. So the 4 on the top, 3 on the bottom. And this is the simplest form that this ratio can take. It's still just like the others. It is identical, but this is the simplest form. So the ratio of the girls to boys at the last dance is 4 to 3, which is the same as 28 to 21. But mathematically, if we can make the numbers smaller, just makes everything better. Any questions on this? Now let's take a look at a different sentence. This one says, in a room, the length of a wall is 24 feet. The width is 9 feet. Can someone tell me what are the 3 ways we can write that particular ratio of length to width? Well, the first way is I can put a 2 in between the two measurements. I can say 24 to 9. So I can say 24 to 9. The second way is I can use a column between the two. So I can say 24, column 9. And the third way I can write this is using the division line or the fractional form. And this is by far my favorite way of writing it. So 24 over 9. So those are the three ways we can write that particular ratio. And again, we will always use the fractional form for any calculations because it's the easiest one to work. So, can I write this particular ratio in a simpler form? And if so, what should I do? I can write this in simpler form, and in order for me to do this, I'm going to break down the 24 and the 9. And the 24, I can write it as several things, but one of the ways I can write it is 3 times 8. I can, 24 is 3 times 8, so I'm going to do that. The 9, I can write as 3 times 3. So far, that wasn't so bad. Now what can I do next, now that I have it written like that? What can I do next? I can cross off the 3's from the top and bottom. 1 3 from top, 1 3 from bottom. So what am I left with? Eight on the top, 3 on the bottom, and that's my simplest form ratio, 8 to 3. It's the same thing as 24 to 9. It's just in the simpler form. Any questions so far? Next, I want to talk about equivalent ratios. In ratios, there are always multiple ways you can write them. For example, let's say we start with a ratio of 3 to 2. 3 column 2, in this case the fractional form of 3 over 2. I can multiply the numerator and denominator by 2 and get 6 over 4. Remember, I can multiply anything by the numerator and denominator as long as they're the same, it's fair game. So if I multiply the top and the bottom by 2, I'll get 6 over 4. 6 over 4 is the same thing as 3 over 2. They're the same ratio, they just happen to look a little differently. 3 over 2 is a simpler form. I can keep going. I can multiply the bottom and the top by 2 again and get 12 over 8. Same ratio, I haven't really changed it. It just looks a little different. Then I keep going, multiply it by 2 on top and bottom again, and get 24 over 16. Once again, same ratio, I haven't changed it. These are called equivalent ratios. Make sense? Good. Now, can someone give me equivalent ratios for the 8 over 4? I'm looking for 2 equivalent ratios that are larger and 2 that are smaller. So let's go on the smaller side first. Can someone give me what is the next equivalent ratio that is just smaller than 8 over 4? Well, if I divide both top and bottom by 2, because I could do that again, I can divide or multiply the top and the bottom by anything that I like, as long as it's the same thing. So if I divide 8 by 2, I'll get 4. If I divide 4 by 2, I'll get 2. So I can write this as 4 over 2. What if I take this a step further? Can I simplify this down one more time? I can. If I divide top and bottom by 2 again, I'll get 2 over 1. sorry. These are all the same so far. Again, I've changed the ratio not at all. Same ratio, just different looks to it. What if I go on the other side? What's the next biggest equivalent ratio to 8 over 4? I can multiply top and bottom by 2 and get 16 over 8. Can I do one more? What's the one right over? (32 over 16). So the ones on the bottom, they are all the same ratio, not changed at all, but they look a little different. The numbers are different, but the ratio remains the same. These are all derivatives of 2 over 1. They just happen to be a little bigger, or if you look at 32 over 16, the rest of them are smaller, but the ratio maintains. You have twice as much on the top as you have on the bottom. So these are equivalent ratios. Any questions? The next thing I want to do is look at a set of equivalent ratios and see if they're the same. I'm going to compare equivalent ratios and see if they are the same thing. Is one derived from another, or are there actually two different ratios? So let's go on the left first. I have 9 over 36 and 2 over 8. And I'm asked to compare them and see if they're equivalent. What can I do? Well, I can simplify them. And that's precisely what I'm going to do next. For the 9 over 36, let's see, right here, I want to leave the 9 as is. How can I write 36 so that it has 9 inside of it? What times what gives me 36, but if one of the multiplicatives is 9? 4 times 9? Sure. What can I do now? I can cancel the top 9 with the bottom 9. So what am I left with? Nothing at the top, so I can just write a 1 and a 4 on the bottom. So I just simplified the 9 over 36 into 1 over 4. It's the same ratio, just looks a little different. It's an equivalent ratio. 1 over 4 is equivalent to 9 over 36. Let's look at 2 over 8. I'm going to leave the 2 as is. What can I write 8 as so that includes the 2 as one of its multiplicatives? 4 times 2? Sure, it's pretty simple. Can I cancel all the 2's, top and bottom? I can. What am I left with? Nothing on the top, so we'll just say 1 and 4 on the bottom. Are these two equivalent ratios? Yes, they are. So in return, 9 over 36 and 2 over 8 are also equivalent ratios, which means they're the same ratio. You have 4 times on the bottom as you have on the top. They just look a little different. So that's how you can figure out if two ratios are equivalent or not. Simplify them to their simplest form, then compare them. Let's take a look on the right side. I have 9 over 12 and 16 over 24. And I want to see if they're equivalent or not. So I'm going to simplify them. 9 over 12. Let's go ahead and work that one out. What can I break the 9 down to? What are the multiplicatives of 9? 3 times 3. What about the 12? What can I break 12 down to? 3 times 4. Can I cancel anything top and bottom? The 3's. What am I left with? 3 over 4. All right, let's take a look at the 16. What can I break 16 down into? 4 times 4. Sure. What can I break 24 down to? There's a few things, but let's choose 6 times 4, because that's 24. I broke it into 6 times 4 because that gives me a multiplicative 4, which I can use to cancel out with the top. So I just told you what I want to cancel, the 4's. All right. That's not simple enough yet. I want to cancel something else. What can I write the 4 and the 6 as to make it a little bit simpler? I can write the 4 as 2 times 2. I can write the 6 as 2 times 3. So I'm going to cancel out the 2's here. And yes, you could have done this on a single step if you really wanted to. So what am I left with? This right here, 2 over 3. Is 2 over 3 and 3 over 4 the same ratio? Because I can't simplify these down any further. Oh, they're not. They're definitely not the same ratio. So 9 over 12 and 16 over 24 are not equivalent. They're different ratios. They look different and they're actually different ratios. So does that make sense how we work those out? Rates and unit rates have a lot of real-world applications. We use them every single day, so it's good to know how to work them out. For example, I have a statement, 90 miles every 3 hours. What is the ratio here? The ratio is 90 to 3. What is the rate? The rate is just like the ratio, except you have to include the units. So it's 90 miles to 3 hours. So the ratio and the rate are very similar, except the rate you have to include the units, because the units in this case are relevant. Now, can I simplify the 90 and the 3? Because I believe that's not in the simplest form. I can. I'm going to leave the 3 alone. And I'm going to write the unit. What can I break the 90 down into so that it contains a 3? Three times 30? Sure. 3 times 30 is definitely 90 and it contains a 3 in there. Can I cancel something out? I can, the 3's. What am I left with? 30 miles on the top and nothing on the bottom. And there's nothing in a fraction, we write just 1. So I'm left with 30 miles to 1 hour. And a more convenient way to write this, we just don't write the 1 here, we just say 30 miles to every hour. 30 miles an hour. That's a speed. And if you ever, most of you will drive a car, it'll be good to know how to convert, let's say, a trip and a speed down to a speed you could actually use in your car. You can look at your speedometer. So any questions on how we get rates and unit rates out of ratios? All right, here's another statement. This one says there are approximately 660 students to 20 teachers at Woodside. What is the ratio here? Well, the ratio is 660 to 20. What is the rate? All I got to do is include the units with the ratio. So 660 students to 20 teachers. So now I want to find the unit rate. And with the unit rate, I'm trying to get the second part of the ratio to be 1. So I'm going to try to cancel it in such a way that the second portion turns into 1. Okay, not a problem. Can I break the 660 into something that has 20 inside of it? Think about it for a little bit. What times what gives you 660, but one of the multiplicatives has to be 20. So the bottom I want to keep is 20. Twenty times 33. That might have not come to you easily, but that's actually it. 20 times 33 gives you 660. Can I cancel something out? Yeah, the 20s. That leaves me with a 1 at the bottom, which is what I want for unit rates. So what is my unit rate? My unit rate is 33 students for every teacher. Which is actually the average class size at Woodside. So that's my unit rate. Questions on how we got that? Now that we know how to use unit rates, we can use comparisons and compare the price of two items that have different quantities for a certain price. And what we use to compare them is the unit rate. So we're going to bring both these down to their unit rates. So I have 10 rims of paper for $30, 3 rims of paper for $12. So first I'm going to find the unit rate for 10 rims of paper for $30. Okay. So I'm going to write it as I'm trying to find how much does each ream of paper cost. So $30 buys me 10 rims. Okay, all right. Can I simplify this? And I want the bottom to be 1. Yeah, I can write 30 as 3 times 10. Can I cancel something? The tens. So the first one is $3 per rim. So that's my very first unit rate. Now I'm going to do the same thing to the other one. 3 rims of paper for $12. So $12 buys me 3 rims here. Guess you're more consistent with my dollar signs. Oh well. Can I break the 12 down to something that contains 3? Three times 4, of course. Can I cancel something out? The 3's. Which yields $4 for every rim. And that's my second unit rate. Which unit rate is cheaper? Which one's more affordable? $3 per rim, of course. So if you were buying rims of paper, this would be your way to go. That's cheaper. You have to buy more, but you end up saving quite a bit in the long run. Questions on how we compare costs? Let's do one more and then we're done. Alright, here I'm comparing the price of songs. I have 3 MP3s for $4, or I can buy an album of 12 songs for $10. Which one's a better deal? I need to find the unit rates, so I'm going to do that. I'm going to set up the first one. $4 for 3 MP3s. Now this is not going to be an easy conversion because 3 doesn't go into 4 evenly. I'll actually have to use long division. Yes, I know, we don't like to use long division. Okay, how many times does 3 go into 4? Once. Point. How many times does 3 go into 10? 3. 1 left. And you can see this is going to be the same repetition. It's approximately 1.3. I can make this more accurate, but I think it's going to be 1.33333. This is good enough for us. We're going to estimate. So we just found that it's about $1.3 per MP3. Okay, now let's find the other one. The unit rate for this one is $10 for 12 songs, 12 MP3s. All right, now let's try to find the unit rate for this one. Long division again. In this case, the 12 doesn't go into 10 at all. So I'm going to put a 0 and a decimal, which allows me to add a 0 here. How many times does 12 go into 100? Approximately 8 times. Well, exactly 8 times, which gives me 96. I'm left with a 4, but I'm not going to go any further. This is good enough for me, 0.8. I'm just estimating very roughly here. So that got us $0.8 per MP3. Again, as you saw, my calculations were very rough, but since I'm trying to compare costs here, I don't need very precise calculations because the price difference is so obvious. $1.3 per MP3, $0.8 or 80 cents per MP3. Buying the album is definitely a terrific deal in this particular case. So this is the one you want to go with. Any questions?